Bismillahirrahmanirrahim. Assalamu alaikum students. Welcome to Pakistan School Muscati Learning, and we are learning from our book Amazing Science Grade 4, and I'm your teacher, Ms. Nida Itlaza. Welcome to the science class, students. This is the continuation of unit number 7, magnets and magnetism. Today's goals are, first we'll discuss about magnets and then discuss the causes and properties of the magnets. And today's work is question number 1. We'll do the remaining part, F and G, in the notebook. And question number 4, fill in the blanks. It's a book work, page number 65. So without wasting your time, let's get started, students. Students, a magnet is anything that produces a magnetic field around it. A material that is magnetic is capable of either being magnetized or being attracted by a magnet. These types of materials include iron, nickel, cobalt, and their alloys, some types of rare earth metals, and some naturally occurring materials such as lodestone. Students, you must have seen variety of magnets around you, a bar magnet or horseshoe magnet, or something that of most of us know about. Apart from these two, cylindrical shaped magnets, a ring shaped magnet, and a spherical magnet are a few more types, but these are not the different types of magnet. These are naturally different shapes of a magnet. Okay. These are found in the natural different shapes of the magnet. So how do we classify magnets into two different types? Yes, you are right. This actually we can see that it's based on their occurrence. One is artificial, which is man-made, and one is natural magnets. The force of a magnet called magnetism, and magnetism works over a distance. When it does not mean that it will touch any objects, you can see that. Just pull the force. If it is the particular material is magnetic, it is moving towards the magnet. Lodestone is the strongest naturally occurring magnet. It is black in color and was first magnet ever discovered. Some other naturally occurring magnetic materials are pyrrhite, columbite, and even basalt. Salt has some magnetic properties, but these magnets are much weaker than lodestone. So there are one more way in which magnets can be classified. Yes, that is simply depends on how they remain the magnetic or they have become a magnetic till what time. They can be classified into permanent magnet or a temporary magnet. As their name, you can see their name. Permanent magnet are what? Yes, that is a permanently they are magnet. They cannot lose the magnetism for a long time. And temporary magnet is for a time period magnets like electromagnets. Magnets have two poles. Okay, there are north poles and south poles. Magnets set up a magnetic field around it. As I can see, I want to show you this, that how magnetic poles are working. If we have two magnets, it's not depend on the shapes. I can take any other shapes as well. I'm showing you just the how can be the force of attraction and repulsion can be behave from a distance. Just watch it carefully. See that different poles attract each other, isn't it? Watch again. Magnet not touch it. Once it is in the field, it will stick to the part. Now watch this one. How the same poles behave. See, repulsive force moving away from the magnet, right? Same pole repel each other. So what are the rules? That like poles repel each other, means same poles repel each other, and unlike poles attract each other. Just watch. Unlike poles attract, same poles repel, moving away, having a force of repulsion. So magnetic force act at a distance. Now we are moving on to the name of the shapes of magnet. It was your book work, question number 2. Question number 5. Yes, question number 5. So name of the shapes of the magnet, the different shapes of magnets you can see and found in your daily life. So these are the names, that these are rectangular magnet, cylindrical magnet, horseshoe magnet, bar magnet. It's also called a bar magnet, U-shaped or round magnets, or ring magnets. Okay. Now, electromagnets, the temporary magnets. As an electromagnet is made by a coil of wire wound round an iron rod. I am taking iron nail. When an electric current is passed through the coils, the iron rod becomes magnet. As you can do this activity and you can enjoy your own electromagnet. We already discussed this part in the face-to-face class, and I show you that how this nails become magnet and how this coil increasing and fever of the coils behave once it is less in number of coils and once it is less in number of batteries or more in number of batteries. So students, so now we are come today's work, students. Now the today's work is unit number 7, question number 1, part F. Describe how to demagnetize a magnetized needle. Demagnetize. The word D represent that remove or reduce the magnetism, the force of the magnetic force. How can we remove the magnetic force? As we already discussed this unit and discussed this topic in unit number 7, page number 62. That is, how can we remove it? Yes, we can remove it by heat a magnetized needle or by stroking it or mishandling. So we are writing that heat a magnetized needle until it becomes red hot, then cool it. So the needle which is magnetized become non-magnetic. Okay. What is a keeper used for? It stops the magnet from losing its magnetism. As I can show you by the picture, this is the keeper. Okay, it protects the U-shape or horseshoe magnet by losing its magnetism, the power of magnet. Okay. Now today's another work is on your book, page number 65, question number 4. Dash is a non-magnetic material. You can write any non-magnetic material name. I write wood. So you can write rubber, you can write plastic, any other, or paper as well. The ends of the magnets are called dash. Yes, poles. The ends of the magnets are called poles. I'm not asking for the name of the poles when I'm asking for the names of the poles. So you can write North Pole and South Pole. Here only they are asking for the end of the magnet. So that is called poles. An object that is made up of soft iron loses its magnetism after some time. Now, an electromagnet is a temporary magnet. E. A compass is an instrument that shows directions using a small magnetic needle which points north and south. Electromagnets are used in telephones and loudspeakers. Now, it's a trivia time, students. What is a natural magnet? Same answer, that a magnetite looks like a dark colored rock is called a natural magnet or found as in naturally in the nature. So what is the full form of Alnico? ALNICO. Al stands for aluminium, Ni stands for nickel, and Co stands for cobalt. So that will be all for today, students. I hope that you enjoy learning. Have a very nice and blessed day. Don't forget to revise the lesson that same poles have the repulsive force. They are moving away and different poles attract each other. They have an attractive force. Thank you, everyone.